Hello, everyone. A very good afternoon. Dear authors and invited guests, welcome to Technical Session 5F. Myself, Richa Shah, and this session will be moderated by me. On behalf of the Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 9th International Conference on Information and Communication Technology of Competitive Strategies ICTCS 2024, Jaipur, India. The ninth edition of this conference is being organized in a hybrid mode. The physical event was held yesterday in Jaipur, and the virtual event is being held today through Zoom on 20th and 21st of December. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations, and each presenter will be given 8 minutes each for the presentations and 2 minutes for question and answers. On 7 minutes, I will raise a gentle reminder. There is another request to all the participants that you stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Before we start, I would like to introduce you all to our session chair. Let me introduce you Dr. Deepika Birari ma'am. Ma'am is working as an assistant professor in the Information Technology Department at Army Institute of Technology, Pune. Ma'am has completed her PhD in the year 2023 and she has a total of 8 years of teaching experience. Dr. Deepika has published over 20 plus research papers in various Scopus indexed and UGC approved journals and conferences. She has over 4 patent and 1 patent grant. Currently, she is associated with the research work in different domains like image processing, machine learning, data mining, and artificial intelligence. um, Welcome to the session, ma'am. Now I'd like to start with the paper presentations. I'd like to call Mr. Mehoob Nazi sir for his paper titled Advanced Arabic Speech Recognitions Through Dilated Convolutional LSTM Networks. So please can you start with your presentation? I guess sir is not in the meeting. So I'd like to call Mr. Arijit Kulkarni for his paper titled An Image Priority-Based Multi-Factor Authentication System. Sir, can you please start with your presentation?
Yeah, sure. Okay, I hope everyone can see my screen.
Yes, sir.
Okay, so hello everyone, I'm Arishit Kulkarni and I'm a student at MPSTME in Mumbai. I'll be presenting our paper, An Image Priority-Based Multi-Factor Authentication System. This is the table of contents which we'll be going through. Okay, so with the rise of multiple password cracking techniques such as brute forcing and other traditional methods of password cracking, we have analyzed the need to come up with a new solution for creating passwords, and thus this project aims to address these concerns by implementing a novel multi-factor authentication system through a set of unique and user-specific means, such as user-uploaded images, and this eliminates the requirements of additional hardware such as fingerprints or IR scanners, etc. We also conducted a user survey for our authentication system, which we'll take a look at later. So the literature survey, what all authentication methods did we look at while creating ours to analyze what's wrong with the current field? So firstly, biometric authentication. These are very secure, but they come with the risk of accuracy issues. And mainly the thing we looked at was hardware dependency. So these are very hardware dependent. They need your fingerprint scanners or retina scanners, etc. One-time passwords, these are very convenient and users highly prefer them, as we'll talk about later. But these are vulnerable to SIM swapping attacks and are also network dependent. Hardware tokens admittedly aren't really used nowadays, but they were highly used in the 2010s and mid 2000s, and they offer a hardware solution, but they are prone to misplacement or theft. Graphical passwords are something which we closely looked at because they are close to our research which we have done. So these are predefined images, but they aren't user chosen, and they are randomly chosen. So they pose a high cognitive load on the user. And image-based authentication, this is something which is very closely related to our technique, but we have proposed a different factor of authentication for it, which we'll talk about later. So the proposed system, since the traditional methods are lacking in some way or the other, this project aims to address these vulnerabilities by implementing an MFA system with an image priority based cognitive factor, which is uploaded by the users themselves, and this enhances both the security and the user experience. So let's look at the block diagrams of our software. So the configuration process, which is the sign up process. Firstly, the user registers their email and password. The password has some characteristics such as containing a specific number of numbers or a symbol which can be chosen by the administrator. After this has been done, the user will upload 9 images from their device, and these 9 images have to be significant to them because the user will have to remember these 9 images and also remember the priority in which these images are sorted. Now, this might seem a bit overwhelming at first, but we have concluded through user experience that users are successfully able to remember the order of these images. And once they have uploaded the nine images, they have to sort them in the desired order, and they have to remember this order for logging in later. This is the sign up page. The user signs up using their email and password, and then selects 9 images. Over here, I have shown the 9 images themselves on the right hand side, and the up and down buttons with which we can order these images based on the priority which we want. Now let's look at the authentication flowchart or the login process. The user starts off and attempts to log in with their email and password. Now this email now in any stage of the whole process, if the user fails three consecutive times, the user will be locked out of their account temporarily. Now we kept this limit at 30 seconds for demonstrative purposes, but it can obviously be improved based on the need. Now the user logs in with their email and password, and if they succeed, they are presented with 12 images. Now these 12 images, out of 4 of these images are from the 9 images uploaded by the user. So that puts a key size of 9C4 over here, and 8 images are picked randomly from the database. So a database of random images also exists in order to further improve the security. So the hacker or an attacker which is trying to intrude into the system will not be able to easily recognize the images. So 8 images are randomly chosen. So 8 plus 4, that's 12 images are displayed to the user. The user then attempts to select their own images from these 12 images. So the user has to select their 4 images, and then the user attempts to sort these images in the correct order. So these are the three factors which we have. One is the password, one is choosing the images, and one is sorting the images in the correct order. And if all this is successfully done, the user is deemed legitimate and logged into the system. So this is the sign in page. The user signs in on the left hand side, and if successful, they are presented with the 12 images. Over here, I have selected the 4 images which belong to me, and then ordered them accordingly based on the order which we previously decided while signing up. And after this, the user clicks on the verify button, and then they are signed in if obviously the images and the order is correct. So now let's look at the results. The key space which has been calculated is the key space formula is this, which is 9 choose 4 multiplied by 365 choose 8. So 365 is actually the number of images in the database which we used. We used the Firebase database, which is developed by Google. And 365 was chosen because it is a sufficiently large number for our use case, but it can obviously be thousands or even millions of images if the organization wants it to be that way. and this would result in a password space of 2 quintillion or 2 into 10 raised to 9. Uh, so this password space is obviously much greater than a password space of say OTP, which usually has maybe 5 digits or 6 digits. So it is obviously more secure than that. And the survey findings, we also conducted a user survey primarily of a college background and also some middle-aged people. So 80% of the users were male. Most of them were between 18 to 30 years old, and most of them were quite accustomed to technology, as you can see. So the authentication process information. So we ran some Python scripts and collected the background data while the users were logging in. And after analyzing the data, we found out that 86.45% of the authentications were successful, while 13.55% were failed authentications. And the average authentication time came out to be around 14 seconds. Now, this is something which obviously needs to be improved in the future, which is the network dependent quality of our proposed system, since the average authentication time varies based on the quality of the internet connection and how fast the device can load the images from the backend. Now, let's look at the ease of use survey. How easy did the users find the system to be? So most of them reported a score of 3 or 4 out of 5. So they were moderately happy with how easy it was to log in. And for the sign up process, most of them were fascinated by it. We conducted some interviews as well. So they were happy to use the sign up process. So they reported more of a 3 or 4 in the sign up process. Now, this is something interesting which we looked at. 57.1% of the users said no, they would still prefer using OTPs or traditional Google authentication systems, for example, instead of our system. So this really, this showcases that users uh, highly prefer convenience even over security. Now they know that the system is more secure than say OTPs or Google Authenticator, but they would still prefer using their own systems which are currently in place. So this gives us some data with regards to the user information and how they prefer convenience over security.
Sorry to
Some would say.
interrupt you, sir. Please, can you wrap up the process?
Yeah, sure. I'm just concluding. So we demonstrated with a 86.5% success rate of our authentication system. Most users were moderately happy, but most users would still prefer using 2FA systems. The future scope is creating lightweight versions, extensive real-world testing, contextual image sets. So, for example, in the USA, you wouldn't use Indian images and so on, and also exploring applications with the application with high security demand sectors. So yeah, that's the references, and thank you for listening, everyone. Does anyone have any questions about the paper? No? Okay. Thank you for your time, everyone. Thank you for listening.
Thank you, sir. Next, I'd like to call Mr. Mokshit P. for his paper titled Comprehensive Web Performance Evaluation of Leading Real Estate Problems. So, please, can you start with your presentation?
Yes, yes. Hey, is my screen visible right now?
Yeah, it's visible.
Yes, sir. So, good morning, everyone. My name is Mokshit. I'm from Amrita University from Bangalore. So, the project that I'm going to present today, it's a comprehensive web performance evaluation for leading real estate platforms. So, these are the contents. So, basically, the the real estate platforms are like the key players in connecting the buyers, the sellers, and even the rent people as well. So the like the success hinges on performance matters like page load speed, responsiveness, and the SEO. So SEO is basically the search engine optimization. So here we're going to evaluate and compare three leading platforms, which we have named as website A, B, and C respectively, across the web performance matrices. So here I'm going to provide the insights into the strengths, the weakness, and the opportunities for the improvement in the evaluations. So the main objective is to analyze the performance of three real estate platforms. So the matrices that we have evaluated are the page load speed, the mobile or desktop responsiveness. So like for certain website, which like where do people access it? Is it through the mobile or the desktop? And even the SEO health. And also we're going to look into the UI interface, the design, overall design as well. So the main goal here is to provide like an actionable insights into the enhancing real estate website performance and improving the overall user satisfaction. So this is a literature survey. So we have mentioned around 9 papers, and the main key references is that here the studies on SEO optimization and its impact on web traffic and visibility. Here the case studies they have done using few websites such as like SimilarWeb and Pingdom for analyzing the website performance, and also they have highlighted the importance of user experience in digital platforms. But the main problem was the gap that we have identified. So there's a lot of like a lack in the holistic comparison of real estate platforms across diverse performance matrices. So the main purpose of the study is to identify and address performance challenges in real estate websites. The outcome is to highlight the best practices for SEO and the responsiveness. So for a certain website, how quickly is it responding? How better is SEO optimization? How better is page load speed? So based on all these factors, we did a comparative analysis. So basically, it helps the developers and the stakeholder enhance the platform efficiency and competitiveness. So by knowing all this comparative analysis, they can improve their website, which can increase the number of user experiences as well. So for the methodology part, like I told, we have used three websites, that is website A, B, and C that we have named respectively. So the tools that we have used here are SimilarWeb, Pingdom, and SEO Site Checkup. So based on these three websites, we have done it. So basically, SimilarWeb is for like getting to know the overall web traffic and current trends, the marketing trends that's going on right now. And the Pingdom, it helped us in getting to know about the responsiveness and the speed of the page, how quickly it's showing. And for the SEO site checkup, it is basically the overall SEO health and optimization. So here SEO is nothing but the search engine optimization. And for the platform that we have used, so for the first website, we have used housing.com. Second one is 99acres.com, and the third one is nobroker.com. So yes. So for the result part, so first materials that we have compared is the web speed and the responsiveness. As you can see here, the website B has the fastest loading time, which is around 1.34 seconds, followed by website C, which had a moderate of 1.39 seconds. Basically, they lack the backend improvements. By improving the backend improvement, they can increase the loading time as well. And the slowest among all three was website A, and we felt like it needs a lot of optimization to be done to have a faster reload speed. And regarding the device usage, we have observed that many users they search all these websites through the mobiles itself. There's a lot of activity going through the mobiles and the desktop. So basically, all these websites are like a mobile first design approach, which for the users. So as you can see here, this is the device distribution as a device distribution for all three websites. So as you can on the left side, we can see the desktop. On the right side, it's a mobile. As you can see, there's a lot of users accessing all these websites through the mobile itself. Like 86%, 82%, 81% of the users are from the mobile. Very less people go through it through the desktop here. So next is the SEO and the user experience. So basically, the for the website, hey, it use like a good amount of local keywords. So basically, in this, it's all about keywords. So suppose for searching certain website, or like searching like for a flat, suppose. So based on all these keywords, it's gonna highlight it. So the stronger the keywords, the better the SEO optimization, and the better the SEO optimization, the better the overall page for overall page for the company is. So for website B, it needed like a regular updates and a strong backlinks as well. And website C, it needs like a better content marketing strategies. We felt like they lacked a lot on the marketing strategies here. So as you can see here, on the left side, you can see there's a lot of keywords that we use. So so such as the flats in Bangalore, flat for rent in Noida, home loan calculator. So all these are the keywords that we use. And next to that, we can see the clicks as well. So based on these keywords, so how many people have clicked, so that is a number there. And so there's a lot of organic versus paid marketing as well. Organic, like more of natural, and paid. So to enhance the to enhance the page, like overall users, some people do the paid things as well. And next we can see the competitive traffic share. These the three colors indicate the three websites that we have used: website A, B, and C. So based on the keywords that we have used and the people users interaction, it defines the overall page responsiveness. So next is the design and content quality. The website A, it had like a good visually appealing and more of a minimalistic design. For website C, it was more of a traditional design, but it was a lot cluttered. That is what we have felt. And website C, it is just like plain, but it had good features as well. And regarding the content quality, website it need to like have a like regular updates with like comprehensive guides. Website B, it has a varied amount of quality and reliant on user submission. So based on the user submission, it was more reliable on that. And for the website C, it needs like in-depth and more diverse content. So next is the security and the geographical. For the security insights, so for the website A, they've implemented SSL encryption and two-factor authentication for user safety. And website B, they followed the standard HTTPS protocols, but we felt like they lacked the threat monitoring system, the advanced threat monitoring system. They lacked in that areas. Website C, they offered a secure transaction, but required like better assistance and overall improvement of user data privacy policies. For the geographical coverage, the website A, they have covered extensive and mostly in urban areas with like a limited rural outreach. So for the website B, it has like a balanced presence across urban and the rural areas. So they have covered both the urban and the rural. Website C, they focus like more on the niche local markets here. So this is SEO and the user experiences. So for different countries, the traffic shares, like how many users are activating, and the group traffic share split as well based on all three websites that you have took. So for the marketing and the CX support, website A, they had like a strong reliance on digital ads and local partnerships. They put more into digital ads here. Website B, they followed like a traditional approach, more like an email campaigns and effective SEO practices. And for website C, they mainly emphasized on the social media outreach. Unlike the other two websites, they mostly dwelled into social medias for their marketing and advertisements, but they lack like the diversified strategies. We felt like they could have learned from website A and B and even implemented ads and other email campaigns, but here they just did social media outreach. So for the customer support, website A, they had like a 24/7 live chat support with quick response times. So for a website, this we felt like a good. It is kind of necessary since there's a lot of users, so they might be facing some problem. So any problem that they are facing, it should be cleared it should be cleared. So if it is cleared, the user he'll continue using the website, and it's a good thing for website here as well. So for the website B, they instead of like a live chat support, they just offered email and call support, but lacked like instant responses. They weren't as quick as website A here. So for website C, they limited the customer support options, and they mainly relied on this community forums. So community forums, there's no instant responses. It takes time. It may take even days as well. So because of this, people might feel why going to the website, they can just change.
Excuse me, sir.
Yeah,
Can you please wrap up?
yeah, sure. So this is the marketing and CX support, the listings, user agreements here as well. So this is the overall traffic share by different countries. So we just did that. So the mainly result is that where website A, it had like high traffic with strong conversion rates. Website B, it had like a moderate traffic, better retention strategies, and website C, it has like a low traffic rate. So these are the matrices which talks about the user experience, content quality, and SEO optimization. So for the conclusion part, we felt like the website A excels in traffic and SEO, but it required like a speed improvements. Website B, it leads in user engagement, but the UI and mobile UX, it needs a lot of refinement here. Website C, it offers unique user to owner model but lags in the performance matrices. The recommendation that we have is they need to have like a improved mobile responsiveness, good backend optimization, and an expanded content marketing efforts. So by incorporating emergency technology like AR, VR, and predictive analysis, so we can improve overall website performance here. And that's it. Thank you. This is a reference here. Yes,
Am I
thank you.
audible now?
Yeah. Yes, ma'am.
Okay. So, one question is there
Yes,
that
ma'am.
what technical measures have been taken to optimize the web performance?
Ma'am, so basically we did like a comparative analysis, ma'am. So we took three websites and we used certain tools, ma'am. So we just observed like the responsive speed, SEO optimization, and traffic. All this we just did a comparative analysis, ma'am.
Okay, and what regarding the measures?
Sorry, ma'am.
What regarding the measures? How you are saying that the system is performing well in this case?
Yes, ma'am.
Okay, what happened if the platform perform with a heavy traffic load or during a peak usage period? Then
So suppose, ma'am, there's a lot of traffic coming. Sometime we observe that certain website it kind of crashes, ma'am, since there's a lot of users coming here. So yes, ma'am. So based on the metrics that we have evaluated are the speed or the speed of the page loading time, the responsiveness, how quick is suppose we click certain button in that website, how quickly is it loading? SEO is basically the search engine optimization. So it is like the keywords, ma'am, how strong are the keywords that they have used,
okay.
the content quality and the security and the user engagement here as well. So these are the metrics that we have evaluated
So,
based.
are you using any page load time metrics like what we can say largest contentful paint is there, or time to first byte is metrics is there?
No, ma'am.
No, fine. Okay. Thank you.
Yes. Yes.
Thank you so much.
Thank you, ma'am.
Thank you, sir.
Thank you.
Next, I'd like to call Miss Srinatha Kamali for her paper titled Enhancing Wrist Strength Using Exogaming. Ma'am, can you please start with your presentation?
Yeah, hi, am I audible? Hey, am I audible?
Yes, you are.
Just a minute, I'll share my screen. I am Sri Ananta Kamali from SSN College of Engineering, Chennai. I, along with two of my teammates and my professor, have conducted this study on enhancing wrist strength using exogaming. This is nothing but having involving some gaming experience within the therapeutic environment to improve your upper arm mobility. So, if you see in today's world, technology has a major role in everyone's lives. We have our mobile phones, tablet, PCs, or laptops. Our days cannot pass without using any of these. And during this, it's difficult to maintain your wrist strength. Prolonged usage leads to some diseases of your upper arm, which includes carpal tunnel syndrome and other diseases. And so this affects your activities of everyday life, and in turn impacts the quality of your life. The traditional rehabilitation techniques often lack engagement, and they do not give you an immersive experience, and hence people don't tend to go back every day and perform. They just tend to neglect the rehabilitation, and they're just forced to accept their impairment and live through their life. Hence we aim to address this difficulty by providing an immersive rehabilitation system which is tailored for such specific group of people to enhance their arm mobility by improving their wrist strength. Here is a study of how carpal tunnel syndrome affects a major population of people. If you look at this, mostly middle-aged people between the age of 35 to 55 are maximum affected due to this syndrome. And the kind of jobs that they undertake include technical, sales, administrative support, or operators, fabricators, and laborers. Their work preliminarily lies on using their wrist for everyday activities and for their occupation. And due to this, if you see on the image here, you can see the parts which get affected due to their prolonged usage of wrist, and this takes a very big toll on carrying out the other activities. So so we tend to address this by having a hardware and a software unit integrated together to give you a gamified therapeutic environment for enhancing the wrist strength. So I'll be covering more in the remaining part of the presentation, but the hardware unit predominantly consists of a microcontroller and an IMU sensor. The software part is nothing but the gaming environment, which is used for your rehabilitation experience. This also includes real-time tracking, and there's progress monitoring, and it also promotes telemonitoring. So if so it also promotes telemonitoring. If you want to do the games at your home, but you're not able to go to your hospital and do, you can still do it, and the doctor or the therapist can still see your progress, and they can still guide you from wherever they are. So, if you look at the need of the study, there's this popular saying which says better late than never. But actually, if you diagnose the diseases at a very early stage, it's easier to provide a good solution, and you can actually get cured completely. So, with our system, we also provide with early diagnosis, and there's objective assessments which give you time to which they give you. I mean, our application provides time to time assessment of how you have performed, and there's different levels within our game, so you can actually level up as you perform better, and this provides high user engagement, and it's very immersive, so the users tend to come back every day, and this in turn improves their everyday life. And it's also very cost effective. Every person in, I mean, people belonging to every sector in the Indian economy can actually use it, and it can be customized for individual needs. So regarding the methodology, so as part of our first step, we went and we interviewed with a lot of physical therapists, and we understood the situation in today's world. We understood how these kind of wrist syndromes are treated, and we carried out a proper study on how we can play a major role in impacting this, how we can improve this situation. And then we chose to come up with a hardware and a software unit, as I mentioned earlier. For the hardware, we have a IMU sensor, which is integrated with a Arduino Uno microcontroller. And for the software, we developed our own games, which for which the game actions will be your wrist movements. So basically, you have your wristband with the hardware unit, and as you move your wrist, these will be translated as gaming actions within your gaming environment. And we tried to make the game as simple as possible so that everyone can understand, and people belonging to every age group and every sector in the society can actually play. And finally, we tested this on a set of 10 people who belong to the middle age and who have wrist usage of over 10 or 11 hours per day. And we analyzed how they felt. Before user testing, we also validated our sensor model using a custom developed gesture recognition model, for which we used MediaPipe, and we compared the accuracy between the two models to actually validate our model. This is a block diagram of our entire process. Like I said, we first did a user requirement analysis, and then we have our technology development. This is again integrate. So the hardware and software units are integrated, and then after validation, it is given out for user testing. Here's an image of a wristband prototype. This is just a prototype. In the future, we aim to make it a very small unit so that it can be carried around everywhere. So for validation, like I said, we had a custom developed gesture recognition model. So our games so the games that we developed are one is the underwater version of the traditional Flappy Bird game, and the other is an endless forest runner. So for this, you'll have to move your wrist up and down, which is wrist flexion and extension. And for the endless forest runner game, you'll move your wrist right and left, which is radial and ulnar deviation. So these are validated with your computer vision model, and then we got an accuracy of over 80%. Here's the gaming environment, like I said. So training environment one is the underwater version of the Flappy Bird. The second one is an endless forest runner. For the Flappy Bird, you'll have to move your hands up and down. And for endless forest runner, there's a lot of obstacles here and there. You'll have to navigate through it and then attain your destination. This also has different levels. So for the hardware unit, This we also visualize the individual axis in MATLAB. Here you can see the movement of X, Y, and Z individual acceleration, and on top is a 3D view of the movement of the wristband. Here is a enlarged view of, it's a combined view of your sensor data. Here is the wristband and it correlates with the game movement. So as you move up, you see the sensor data. As the hand is up, there's a turtle, which is the game player within our game environment. It moves up. And as you move your wrist down, it also moves down. So this is the comparison between the gesture recognition model and the sensor data. The blue lines here are the computer vision data, and the red lines are the sensor data. Here, as you see here, we got an accuracy of over 81%. The precision was also pretty high, which is 83%, and the recall is over 85%. So this was considered safe, and it can be used for people. Here is a confusion matrix. So as you look at the outcomes, we have come up with very personalized programs which can be customized as per user needs. If the user has been if the user needs a different kind of environment which they have already always thought about, we can still use it in that case, and it gives a very immersive nature. So when they actually play the game, the therapeutic needs are also satisfied, but it also promotes their experience, and so they tend to keep coming back again, and so the entire process is regular. Most of them don't drop out in the middle of the study or in the middle of the program. And we also provide progress monitoring. So every now and then, you know how you have improved. And it also gives you data of people undertaking the same program. And so you get boosted every now and then looking at your peers, and you tend to strive more and more. And it is a very cost effective method, and it's very accessible. It only requires your PC and your wristband, and you can do this exercise anywhere, anytime, as per your advice of your therapist. And this in turn improves your quality of life. Your functional ability has improved, so the range of mobility has improved, and this also strengthens your wrist.
Excuse me, ma'am, can you please wrap up?
Yeah. As in the future, we try to we'll try to incorporate Bluetooth technology, and we also aim to include haptic feedback to enhance the experience. And will also be able to. We also want to develop more customized environments specifically for upper arm rehabilitation with different levels and based on the user preference. So these are the references we used. Thank you very much for the opportunity. Are there any questions?
Yes, am I audible?
Yes.
Okay, so one question is there that how sustainable is this exergaming as a long-term approach to risk training and rehabilitation?
Well, ma'am, so there's different kinds of different kinds of people who are affected by different diseases, and for some people who are pretty normal, but who have a prolonged usage of their system, prolonged usage of electronic gadgets, they still have issues with related to their wrist. So if they have it as a package with them in their PC or in their own devices, they can just play it every day in the morning or in the evening as per the advice of therapist. So if you just tell them to routinely do their wrist up and down or wrist right and left, or you give them some device which stimulates them to do that, they wouldn't really follow it. But if they actually play this game, you also navigate through the obstacles and you reach your destination, which also has very good visual feedback. But in the meantime, your therapeutic goals are also achieved. So if you exceed the usage, your therapist always has a view on how well you have played. So based on your progress, they can also control your usage.
Okay, and who is the target audience for this risk training exergames?
Well, for our study, we chose healthy individuals who have who have wrist, upper arm usage more than 10 or 11 hours per day. But it can also be adapted to use for other stroke rehabilitation or PD rehabilitation purposes as well, when you want to aim at improving your wrist strength specifically, or
Okay.
even other
And
diseases.
what efforts will be taken on the users' engagement? Means they should be get engaged with this exercise and should not be diverted.
Yeah, so we have, for this study, we had specifically chosen the games that people mostly play. So this Flappy Bird and the Endless Runners are more commonly played. Everyone people in every age group understand the game. But if you have some other special children, or if you have some other specific PD patient, we can still customize it according to their needs. So
Okay. So are you telling about the duration and the frequency of the sessions?
you can also modify the theme settings.
Okay. Fine.
Even the duration, it will be given by the therapist.
Fine. Fine. Thank you.
Thank you, ma'am.
Moving on next, I'd like to call Ms. Deepa ma'am for her paper titled Comparison of Inertial Measurement Unit with a Motion Tracking System for Human Shoulder Range of Motion. Ma'am, can you please start with the presentation?
Yes, thank you. Am I audible?
Oh, yes, ma'am.
Yes. Good afternoon, I'm present here. I myself is Deepashri. I'm going to present the work called Comparison of Inertial Measurement Unit with the motion tracking system for human shoulder range of motion. So I'm from Sri Subramanian College of Engineering, India. So the aim of the work is we build a low-cost based inertial measurement unit for assisting a human shoulder joint range of motion in comparison with a commercially available motion tracking system. The main objective of our study is to build a low-cost wearable IME model to track the shoulder joint angles and to directly compare the low-cost IME sensor with the standard commercially available sensor calibration method for the shoulder rehabilitation application. So I'm going to introduce why we are going for the low-cost based system. So the basic is if a person is having a musculoskeletal disorders, they can go with the rehabilitation session. So a survey was there, like the WHO, that is the World Health Organization, launched the Rehabilitation 2030 initiative to draw a main attention to meet the rehabilitation worldwide. There is a survey. This is from the Australia. They have did this survey. So there are various pathoanatomic diagnoses classified for the musculoskeletal disorders. So one is the rotator cuff tear or tendinopathy, and we have adhesive capsulitis, glenohumeral anterior instability, and SLAP lesions. So these are all the kind of musculoskeletal disorders that affect the musculoskeletal. So the main introduction is we have a inertial measurement unit, that is the IMU, that has revolutionized human rehabilitation for monitoring and analyzing movement, that is the human movements. So why we are going for an IMU? It is used widely in rehabilitation and healthcare for motion tracking and analysis, enabling clinicians to monitor patients' progress remotely, providing detailed biomechanical data for therapy adjustments, medication dosage response, individualized therapy, and lifestyle changes. So why we are going for an IMU sensor? It is having a built-in accelerometer, gyroscopes, and magnetometer. It is a low cost and it is easy to wear. So this is the basic methodology. We have a goniometer. So it is nothing but an instrument that measures ankle motion at a joint. And we have a motion tracking system, that is a commercially available motion tracking system. And we have a custom-made inertial measurement unit that is tied up on a person at a physiological joint, especially. And we have the output from the motion tracking system is given from the software, that is the motion tracking software system. And from the output from the initial measurement unit, both the things has been compared, and the initial measurement unit will be compared, will be calculated by using a Euler's calculation, and the comparative analysis is taken, and their respective root mean square error is calculated. So this is the basic methodology. So how the data is acquired by using an IMU and then motion tracking system. So the IMU we have used is MQ6050, and it has a sampling rate of around 8 kilohertz, sorry, 8 hertz. And the sensing components, we have a accelerometer and gyroscope, which is a 3-axis, that is a 3D. And in this work, we have used Bluetooth connectivity for Bluetooth connection, that is the Bluetooth module. And it is also having a support I2C interface communication protocol for communication. And the other side, we have that is the motion tracking system, which is nothing but the Movella, which is a commercially available motion tracking unit. So it is having a sampling rate, and it is adjustable up to 120 hertz. The sensing components also, it is having a gyroscope, accelerometer, and magnetometer. So the Bluetooth connectivity is already available with the MTS, that is the commercially available MTS. And it is also having a SDK support system. So this is what the angle calibration we have done. We have used a goniometer for calibrating the MTS, that is the motion tracking system, the Movella. And the data is recorded here by using a stopwatch. We have done all the calibration. So this is the output from the MTS, that is the motion tracking system. So the design and development of IMU, we have a IMU which is connected by using a battery, which is powered by a battery. It is the IMU is connected using a Arduino Uno microcontroller, and we have a Bluetooth module for connectivity. So the experimental protocol, we have done a shoulder adduction and abduction exercise for the patient, and we have done 4 trials. So we have both the developed IMU and commercially available MTS has been placed one over the other, and the values are not biased. So the calibrated MTS and the proposed IMU sensor are located in the same region for coordinated joint ROM measurement. Simultaneous analysis of joint movements, combined data from both the systems are then used for the comparative analysis. So it provides real-time data on measurement, and it improves accuracy in joint kinematics measurement. So these are all the results. So these are all the results. First, we can see the simultaneously acquired range of motion were plotted for further analysis. Offset along the x-axis, we can see there is an offset here for the 2 trials, first 2 trials. So it is due to the difference in switching on times, and this does not have any implications towards range of motion accuracy. And you can see from this, you can infer that from 0 to 10 degrees, the initial offset along the y-axis is observed only for the first 2 abduction and abduction cycles. So the low cost, that too on the low cost IMU system, not in the motion tracking system, that is the commercially available motion tracking system. So this can be attributed to the setting time of the IMU sensor, indicating that the system requires a time to stabilize before obtaining accurate measurements. So from the 3rd trial, you can see here that it is matching the MTS, that is the motion tracking system. RMSE for, and then we can see the RMSE, that is the root mean square error. So the RMSE for adduction and abduction have been plotted to taking 10 degrees intervals of angles, that is 0 to 10, 10 to 20 likewise. Reliability of the collected data can be accessed as expected, and the RMSE for angles between the range 0 to 10 degrees are high for both abduction and adduction owing to angle offsets. So in order to improve accuracy in the 0 to 10 degrees, encourage the participants to take 2 or 3 practice trials as warm-up to allow for the setting time of the sensor, so before proceeding with the actual measurements. So the inference we have is, so proper placement of the IMU sensor and its orientation with respect to the limb plays a vital role in the accuracy of measurements. So initial trials show some deviations. So this can be due to the settling time of the sensor, that is the IMU sensor. So by considering few trials as warm-up, the measurement error can be reduced. So the findings suggest that upon taking the above mentioned precautions during the conduct of experiment, reliable ROM measurements are possible by using our low-cost IMU sensor, which can cater to numerous custom applications that are of interest to the research community. So the summary, we have systematically compared the widely available low-cost IMU device with a commercially available MTS for a human shoulder range of motion. The results suggest that the IMU calculator ROMs are in agreement with the MTS units, that are motion tracking system units. However, care should be taken in the placements, offset adjustments, and allowing sufficient settling time for the IMU devices to avoid any potential measurement errors. So these are all the references, and that's about the presentation. Are there any
Okay,
questions?
Yes, ma'am. Am I audible?
Yes, ma'am.
Okay. So, what is the frequency of data sampling you consider in both IMU and motion tracking system?
Actually, we have kept 10 hertz.
Okay.
Hmm.
And what are the limitation here in terms of the resolution and accuracy, again related to both IMU and motion tracking system?
So the limitation we have is like the initial settling time is different for IMU, whereas in MTS it is giving the accurate answers. So we have to, as I told you, we have to give some settling time and consider the first two trials as a warm up session, and they have to practice prior for going and then going for the, they can go for the ROM measurements.
Okay, so there are any a thing that is needed to filter out the noise or any signal instability? Any method you are applying for this? Is any issue related to the noise from the sensor in either the system, and how is the signal noises get minimized here?
Actually, this is the raw data we have got. We haven't found any noise to be used. That is the filter to be used. So this is the data that we can conclude that we can both the systems are working in a proper way.
Okay, but
We
you should
haven't used
consider
any
this in
filter.
as an parameter for your
Sorry,
further enhancement.
sorry.
This you can consider as a parameter for your future
Yes, ma'am.
scope.
Yes, ma'am. Yes,
Yes.
ma'am. The angle. So as you all know, the adduction and abduction angles for the human joint rotation is like 0 to 180 degrees. So we are
Right.
the person who is doing, he can achieve probably up to 160 or 170.
Okay, fine. Thank you from my side.
Yes, thank you.
Thank you, ma'am.
Thank you.
Now I'd like to call Mr. Vikas Kumar Jain for his paper titled Exploring the Impact of ICT Tools on the Learning and Development of Children with Autism Spectrum Disorder. Sir, please can you start with your presentation?
Yes, ma'am. Yes, ma'am. Am I audible, ma'am?
Yes.
Good afternoon to ma'am. Just please confirm, am I audible?
Yes,
Yes,
you
sir,
are.
you're audible.
Okay, okay. Thank you, ma'am. Thank you. Okay, so the title is Exploring the Impact of ICT Tools on the Learning and Development of Children with Autism Spectrum Disorder. My name is Vikas Kumar Jain and my co-author is Meenakshi Tripathi from Department of Computer Science Engineering, Malviya National Institute of Technology, Jaipur. So these are the contents. Now we will discuss about the introduction. So actually this research examined the role of information and communication technology tools which enhance the learning and development of children with autism, focusing on their potential application in the field of human resource. This study evaluated different tools, including mobile application, website, desktop platform, augmented reality, and virtual reality technology to identify features that can support the development of communication, behavior, and language. The key feature analyze including bilingual support, performance tracking, interactive games, ease of navigation, and adaptability. So this study overall evaluated 43 ICT tools. And this study specifically compared the effectiveness of low-tech, mid-tech, and high-tech educational tools for children with ASDM. So we have divided all these tools into three basic terms: low-tech, mid-tech, and high-tech. It examined tools such as mobile application, gamified learning, AI-driven system, VR, virtual reality-based therapies to evaluate their features, ease of use, and overall impact. The objective is to identify which tools work best in various education environment, including home, specialized therapy, and setting. The finding of this research will provide valuable guidance for educators, parents, and policymakers, helping them make well-informed decision about choosing and implementing the right tools to support children with ASD effectively. So this is the one summary from 2000 to 2020 from ADDM, where we can find out how many number of children are affected on this autism. So this is from 2000 to 2020.
Excuse me, sir.
Yes, yes.
Do you not have this in a PPT format?
This is the PPT.
This is a PDF format, but it's fine if you don't have it right now. But other
Actually, ma'am,
presenters,
this is the latex.
please make sure it's a PPT.
No. So I have created this PPT over latex, and we have downloaded it in the form of PDF.
Sure, okay, no problem, sir. You can continue.
Okay, thank you. So what are the objective of this study? So this study explore educational app website. We have already discussed tool designed to support individual with ASD. To organize the analysis, the tools are grouped into three categories based on their features and technology complexity. The first one is low-tech tools. These include simple solutions like communication board and visual aids that are easy to use and do not rely on advanced technology. Then mid-tech tools, these involve moderate technological capacity such as multimedia supports and basic interactive features, offering more engagement and functionality. Then high-tech tools, these including advanced system using technological like AI, virtual reality, and adaptive learning platform that provide personalized and immersive experience. So this classification ensures that the tools are matched effectively to the specific need and educational environment of individual with ASD. Okay, so for this research study, we have included 4 groups, 9 AI tools, 8 virtual reality tools, 15 mobile applications, and 11 websites. So total of 43 tools. By analyzing the totals of 43 tools across this category, the study aims to assess how effectively they meet the educational and needs of individuals with ASD in different environment. Then the second case, we have find out different features, the usability features and accessibility features of tools, which play a crucial role in creating solutions that are effective, inclusive, and adaptable for wide range of users, particularly those with different needs. So the first one is usability features. The tool is designed with that ensure ease of use for everyone, regardless of their technical skills. And accessibility features are designed to ensure that educational tools are usable by everyone with different ability and different needs. So for research or analysis, we have found out these 20 features from app 1 to app 13 based on category using usability features, and from app 14 to app 20, which are accessibility features. So for example, usability features like app 1, that design is simple and easy to use for everyone, provide support through FAQ. This is category into F2, accessible on Android, iOS, web application without internet connection, or like this one, like a user AI to adopt, improve the tool based on user needs. So these are some user features. Accessibility, that means there are some advanced features like gestures, voice commands, visual implements, screen readers, keyboards, how we can use the tools with keyboard, text to speech, visual schedule, and includes some fun or educational interactive games to make learning engagement. So these are features from F1 to F20. Now, third one, we categorize already discussed 3 category low tech tools. Low-tech tools are simple. This do not require any advanced technology. These tool includes like flashcard, visual settlers, and communication boards with pictures. Medtech tools are more interactive, but still less complex than high-tech option like text-to-speech or video. High-tech tools use advanced technology such as AR, VR, like real-time speech or gesture recognition. And based on the features and from F1 to F20, and we just categorize how many number of tools are available according to the usability and accessible features. So this is the graph which visual representation of all the features with respect to number of ICT tools. Okay. Now I will show you one more tables after this future is a direction and conclusion. Actually, this is not fit into the PPT. So okay, what are the some more future direction? So the first one, exploring some new technology. Apart from basic features, future research should explore some advanced technologies like AI and ML. Second, long-term benefits. While many ICT tools show immediate improvement, the long-term effect on a child development are still not well understood. More research is needed to examine how consistent use of these tools impact important development like social behavior and independence over time. Affordable and simple tools, low-tech and mid-tech tools such as visual boards and basic education app are more affordable and accessible, especially in the area of few resources. Adapting to cultures and language, many existing tools do not address the need of children from different cultural or linguistic background. So future research should focus on creating tools that are sensitive and can be adapted to the various language. Then personalized learning, the next generation of tool should be able to personalize the learning experience for each child with the help of AI.
Excuse me, sir. Can you
Yes,
please
yes,
wrap up?
yes. Uh, okay. So last one, combining ICT with the schools. Research should explore how ICT tools can be integrated into traditional classroom by combining digital tools with standard teaching methods. We can offer a more comprehensive approach to education. Okay, like a conclusion. So information and ICT tools are vital in supporting the learning and development of the children with autism spectrum disorder. These tools, which include visual aids, AI, and VR that enhance communication. High-tech solution like where AI offer customized experience, what can be expensive and complex. The development of ICT tools should focus on improving personalization and inclusivity. Tools should be designed to cater to children from diverse cultural and linguistic background. By involving educators, parents, and therapists in the design process, the tools can be better tailored to meet the unique needs of children with ASD, helping them succeed both academically and socially. Okay, so this is the conclusion, ma'am. Like I want to share one more, only one last pictures where I have conclude all these. Okay, this is the complete analysis where we have mention all tools name, what are the labels, high tech, mid order, low tech, and where it is available like app, VR, mobile app, website, and what features are available. So this is complete analysis of ICT tools. Okay, thank you, ma'am. Any query, please, I'm happy to answer.
Okay. And the question from my side is, what are the available as you are using the ICT tools for the different level of SD severity, means different level of that children's having the severity of ASD, then how customization you are providing?
Okay, ma'am, actually, this is just analysis. So we have already divided these
So
features
you are
into.
not providing any solution to this?
No, ma'am. Actually, this is just available tools analysis.
Okay. And there is no kind of feedback mechanisms as well?
No. This is just exploring the currently available IC tools. So basis on this analysis, we can find out what we can customize or we can give some feedback and develop some more advanced technology.
Okay. So here you are integrating, means you are doing the study where there is an integration of their behavioral therapy or maybe a speech therapy, any social skills training, etc. You are taking in consideration in your analysis?
Yes, ma'am. We are trying to considering, but we have not found out all the details. We will explore in future, ma'am.
Okay, fine. Okay, thank you.
Thank you. Thank you very much.
Thank you, sir. Next, I'd like to call um, Anushri ma'am for her paper titled Hypothetical Protein Classification Using Neuro-Chaos Learning Architecture. Ma'am, can you please start with your presentation?
Am I audible?
Yes, yes.
Is my screen visible?
Yes, ma'am.
Yeah. Um, Okay. Good afternoon, everyone. My name is Anushree M. I am a research scholar from Amrita Vishwavidyapitham, working under the guidance of Dr. Pramod P. Nair. Today, I will be presenting my work on hypothetical protein classification using NeuroChaos learning architecture. So let's begin. So these are the things that I will be discussing in this presentation. Moving on to the abstract. NeuroChaos learning is a chaos-based learning algorithm inspired by the chaotic firing of neurons in the human brain. This method suggests a combination of traditional machine learning algorithms with feature transformation, neurochaos feature extraction, and modifications based on chaotic maths. The architecture used here can be viewed as an application of chaos as a kernel trick applicable to various machine learning algorithms. In this work, we use neurochaos learning to predict whether a given protein is hypothetical protein or not. This is a significant area of research in bioinformatics. The F1 scores of conventional machine learning techniques, ChaosNet, and the NL algorithms with noticeably less training data are compared. Introduction. The NL algorithm is a nonlinear chaos-based learning algorithm inspired by the neurons in the brain. It has its foundations on the principles of chaos theory and the ChaosNet design proposed by Harikrishnan in 2019. ChaosNet is an artificial neural network architecture inspired by the chaotic aspects of brain for classification problems. ChaosNet has demonstrated the capacity to perform better than standard machine learning algorithms in challenging classification tasks with far less training data. Thus, a unique learning method called NeuroChaos learning was recently proposed, which was inspired by the ChaosNet architecture. This approach proposes a novel mix of classic machine learning algorithms with NeuroChaos-based feature transformation and extraction. As mentioned earlier, the dataset that I have chosen is of 9-point schema hypothetical proteins. Hypothetical proteins are those that are predicted to be expressed in an organism, but no evidence of their existence is known. These proteins are of great importance as many of them might be associated with human diseases, thus falling into functional families. They play an important role in understanding biochemical and physiological pathways, for example, in finding new structures and functions, markers and pharmacological targets, etc. The 9-point schema hypothetical protein dataset has 9 features and 300 instances, of which 106 instances from the positive class representing hypothetical proteins and the remaining 194 instances from the negative class. Methodology. The NL architecture comprises of 3 components, namely feature transformation, NeuroChaos feature extraction, and classification block. The first block is the feature transformation block. It consists of a one-dimensional generalized Lurot series neurons as the input layer. Each of the one-dimensional GLS neurons used here is a skew-tend map defined by this equation. For an n-dimensional input vector, n number of GLS neurons are chosen in this block. Every GLS neuron has 2 parameters. The first one is the internal discrimination threshold represented by B, and the second parameter is the initial activity value Q. Next block is the NeuroChaos feature extraction block. It consists of these are the inputs. It consists of input features, the x1k, x2k, etc., xnk obtained from the dataset. After normalization, these input features are sent to the feature transformation block. For each input feature xik, the corresponding one-dimensional GLS neuron fires with an initial value q to form the following neural trace. When these chaotic neurons reach the epsilon neighborhood of xik, their neural trace stops. The topological transitivity property of chaos mathematically guarantees that the neural trace will stop. Next one is the feature neurochaos feature extraction block. Here the transformed representation of the input feature xik is converted to a four-dimensional vector. The four features extracted from the neural trace are firing time, firing rate, energy, and entropy. Next, and the final block is the classification block. In the NL architecture, as mentioned earlier, two types of classifiers can be used, either the ChaosNet architecture or the ChaosFX with other machine learning architecture. In ChaosNet architecture, a mean representation vector is calculated to represent each class, and then a simple cosine similarity based classifier is used for decision making. Now, in the next type of classifier, that is the CFX plus ML classifier, it can be considered as a hybrid neural network architecture. Here, the CFX vectors obtained are directly sent to any of the simple machine learning algorithm for classification. Moving on to the results. Since our dataset is imbalanced, we have used the macro F1 score as our performance metric to compare various algorithms. CFX vectors retrieved from this input data are combined with traditional machine learning algorithms like Gaussian Naive-Bayes, random forest, AdaBoost, etc. to create hybrid models. These features are also passed to cosine similarity-based ChaosNet architecture. The hybrid models are trained in two training regimes, a high training regime, which uses more data instances, and a low training regime, which uses fewer data instances per class. The hyperparameters B, Q, and epsilon of the NL architecture are tuned using Optina. The standalone machine learning and CFX plus ML algorithms are trained with 80%, 50%, and 20% data, and the remaining is used for testing in the high training regime. The macro F1 scores obtained are tabulated here. In all the cases, an increase in performance of the hybrid CFX plus ML algorithm can be seen when compared with ChaosNet. Also, while comparing the results of standalone ML with CFX plus ML, CFX plus ML is always giving a superior or a similar comparable performance as that of the standalone ML algorithms. The performance boost of model A over model B is given by this formula. And this is used to compare the results in the low training regime. The value of performance boost in the table indicates that there was always a boost in the performance. The check mark indicates the boost. Performance boost in the performance of CFX plus ML compared to standalone in the low training regime. This figure also indicates the same boost in performance of CFX plus ML in the low training results. Conclusion. So in this work, we have compared the performance of CFX plus ML algorithms with the traditional machine learning techniques and ChaosNet for classifying hypothetical proteins. As a result, we have understood that the Chaos feature extraction has improved the performance of all the machine learning algorithms considered. Also, we have noticed that the boost in low training regime, especially with 10 to 20 samples per class, is very significant. These are some of the references that I have used for this work. Thank you for everyone. So is there any questions?
Yes, very good presentation. My
Thank you, ma'am.
question is, how does this NCLA will handle the non-linearity in the relationship if it is found between, say, the protein sequence features and the classification label? Non-linear data, will it get handled?
Yeah, ma'am. Actually, the data is converted into a nonlinear form using this NL architecture, using the chaotic maps.
And what type of features you are extracting from that protein sequence? Like,
Yes, ma'am. Actually, we have 9 features in
uh,
the raw data. So we will convert each of the feature into each of the feature will get converted to 4 different features that are the mentioned here, that firing time, firing rate, energy, and entropy. This will be what obtained from the neural trace defined here. This T represents the chaotic map mentioned earlier.
okay. And are you dealing with any missing data or incomplete data in terms of pre-processing of your protein data?
No, ma'am.
Are you
Actually, this
applying any data normalization or standardization over here?
yes, ma'am. The normalized data is actually passed on to the feature extraction block.
Okay, fine. Thank you.
Thank you.
Thank you, ma'am. Moving on next, I'd like to call Mr. Naitik Jain for his paper titled Pod Bias, an advanced bias detection system for YouTube podcasts using NLP and transformers. Sir, please can you start with your presentation?
Ma'am, I've sent you a request to let me present. Can you just accept it?
Yeah. Can you try again?
Yes, so starting a podcast bias where I, Rishabh Jain and Rishi Jain have created this project where we are detecting bias in long form podcasts using NLP and transformers. Yeah, so table of content for the presentation is introduction, our objectives, what was the scope of the of the project, literature survey, and what is the research gap in the industry as well. We also extend the tools and technology used, the implementation, and a demo video is also there where we have concluded the project as yeah. Yes, as an introduction, podcasts are very important in influencing and shaping opinions. And for us, identifying biases in the content of podcast is very important because it it is like influencing people. So we have made this project regarding that problem, where there were podcasts which are very biased towards right leaning or left leaning, depending on podcasts. Yeah, four biases. Yeah, so our objective was to detect bias in the guest speeches, where podcast guests we are detecting bias of podcast guests, where we are using NLP techniques. We are also creating a visual streamlit dashboard for that bias detection, and then delivering that bias analysis. Yeah, so our scope covers four main biases, where political, sociological, economical, and racial bias, where we have generated LLM generated label data for training purpose, where we are generating da- sentences and the current corresponding labels of it, and we are using that data to train the model, yeah, and then still showing that in the streamer dashboard. Yeah, so for literature survey, we have done three major research paper surveys. First was the automated media bias detection, where we have learned about neural networks, non-verbal bias detection, etc. Yeah, and for the second research paper, we have done bias detection using textual representation of multimedia contents, where we have learned about the methodical foundation of using transform models to uncover implicit biases. Yeah, and the third was the sentiment problem, where we have understood the use of sentiment analysis for podcast detection, podcast bias detection. Yeah, yeah. So the research gap was in the long format conversation content. There were no research paper based on that, and we thought about using a program for using training a lot of data. There were no data available for it, and we thought it would be helpful. Yeah.
So the tools and technologies used are first of all, programming language that we used was Python, and the frameworks and libraries are as follows. We use Transformer, also known as SBOT. Speech to text, we use Whisper to convert the YouTube speech into text format. For creating embeddings, we used CodeBert, and for the classification model, we have a standard neural network model. The other tools that we used were Streamlit for visualization, and Jupyter Notebooks for experimentation, Google Colab and Cackle for model training because they provide us excessive computational resources. And the data set that we used were YouTube captions plus the Whisper generated transcripts and the LLM generated data set. The design details are as follows. This is how the entire project works. So as an input, the podcast audio files is fed into the model. The transcription takes place using Whisper and it converts it into text. Pre-processing that is generally done on NLP projects is provided here. That is text cleaning, tokenization, and embeddings are created using CodeBot. Bias classification is done by multi-level classification using fine-tuned models that we have ourselves generated. And the output identifies the bias categories and the respective probability scores also provided. So this is the entire methodology that is followed by our project. Firstly, the data collection takes place, then the data pre-processing takes place, model training takes place, and then bias detection takes place. I would not get into details of it because then it would get a little too long, but you guys can go through it. Failed approaches. We also tried a few different approaches to tackle this problem. One of them was using LDA. But the problem with LDA is that it identifies themes and topics within the text by clustering words that commonly occur. But biases are more subtle and nuanced, and they require analysis of sentiment or ideological stance rather than just word co-occurrences. So yeah, and LDA also struggles with short text, which is one of the shortcomings of that. We also tried name entity recognition, where bias is often not directly linked to the mere mention of entity, but how it is discussed. Named entities don't always signal bias, as some entities may appear across various contexts without inherently indicating biases. And detecting bias, especially for categories like political or economic, depends more on opinion or perspective rather than the presence of a specific named entity. So the implementation specifications are as follows. Data cleaning and tokenization. We remove special characters, converted text to lowercase, tokenized, and remove stop words. We use TF-IDF vectorization for numerical representation. Model training was done using separate neural networks trained for each bias type, that is political, economical, cultural, and racial. Feed forward neural networks with dropout layers and categorical cross entropy loss were used. Bias detection was done using, so it was classified in sentences from left-wing liberal, right-wing conservative, or neutral. Computed probabilities for ranking biases by confidence. Bias score calculation is basically an aggregated score to give a proportion for each class, simplifying interpretation with a combined score. And summarization, we split long transcripts into manageable chunks, summarized and combined the results. So these are the graphs showing the model training results over here. And this does not show how our model performs in real time. Rather, it shows how well our model has been fine-tuned to the problem statement. As you can see, there is the minimum amount of F1 score that we have achieved here is 98%. And this is our training and validation loss over the epochs. This is a demo video that I'd like to show with by skipping parts because it would take too long. But here it goes. So you paste a link of YouTube video and then select the task that you want. Here I've selected both, that is summarization and bias detection. So it converts the audio into transcript. Then the next step is initializing the transcript analyzer and then is summarizing transcript. So once it's done, you can see how a brief gist of the entire podcast or the YouTube video is given. Here we can also see the bias detection results and the overall bias of the podcast using aggregated scores, and also a pie chart showing how left, right, or neutral was the podcast uh, intuitively. Conclusion to this project demonstrated a novel approach to bias detection in podcasts using NLP and speech-to-text technologies. The use of transformer-based models enabled effective categorization of biases, effective in bias detection, and it is highly accurate and scalable. And it also has practical applications like media analysts, journalists, content creators, and researchers can use this to get insights about how their videos are performing and how, if they are getting tilted towards a particular bias. The key takeaways are importance of dataset diversity, potential for using this system in content moderation or media analysis. Future scope, we can perform real-time bias detection that enables live analysis of podcasts during streaming itself. We can expand to other languages. Sadly, for now, we are only detecting biases in English, and the sentiment and tone analysis can also be added and inculcated into this model to create a more holistic experience. We also have an interactive dashboard. We can also have an interactive dashboard which provides an easy to use interface for media analysts to explore bias in podcasts. So these are the references. Thank you so much for your time.
So very good presentation from your side. Only two questions from my side.
Yes,
Am
ma'am.
I audible? Okay.
Yes, ma'am.
The first is that what training methods and algorithms are used here to optimize the performance of your transformer models?
Okay, so the first question that you asked is training as such. We ourselves created sentences and labels using LLMs to give us a pseudo labeling task was performed using LLMs, and it gives us labels, and using that we trained a neural network and performed hyperparameterization on that to get optimal results, where we can fine tune and tweak things like epochs, batch sizes, etc., which helped us optimize this. What's the next question, ma'am?
Algorithms that you have used to optimize the performance.
Ma'am, we've just used simple neural network architecture and hyperparameterization, which
So
in
you have
its
taken transfer learning in consideration?
transfer learning, no, ma'am.
No. Okay. And the next question is, what are the main challenges you faced while detecting the bias in your YouTube podcast?
So, ma'am, the this is a bit away from the topic, but the main problem over here was the data scarcity. We had no particular data which could
Like,
show.
I'm just talking like speed of the speech or something like informal language. So,
Yeah, so
are these parameters are the challenges for you?
the good thing about that was that Whisper is quite advanced now,
Uh,
considering it has so many versions and it has evolved over time. So it is able to capture like 90% of the times whatever is actually being going on and what the user or the speaker is trying to say. So in that particular paradigm, we did not have any problem, but the problem we actually faced was the data scarcity. So we had to train our LLM to generate sentences and label them.
okay. And what future improvements you are planning to just enhance the accuracy or coverage in this bias detection?
So firstly, we are planning to make it multilingual because podcasts are not only in English.
That is what the important, yes.
Yeah. So first is that, and the second thing is because of lack of computational resources, our model takes quite a lot of time, like 2 minutes something to detect to create an
Are you
output.
using any high performance machine to evaluate this? Any HPC
Uh,
facility?
no, ma'am, not really.
Okay, so I will suggest you, if you go for it, then it will definitely benefits you. In
Okay.
number of institute, the HPC facilities are available in, also our institute is providing the HPC facility for the researchers.
Okay.
So if you take the help, then it will definitely increase your performance and
Okay.
the time will get reduced.
That's great, ma'am. Thank you so much.
Okay, okay. Thank you from myself.
Thank you, sir. Moving on next, I'd like to call Mr. Enak Bukai for his paper titled Proactive Approaches to IoT Network Security, a review of threats and strategic amelioration techniques. Sir, please can you start with your presentation?
Hello, ma'am. Please, am I audible?
Yes, sir.
Please, is the screen visible?
Yes, it's visible, so you can start.
Okay, okay. Thank you. Thank you so much. My name is Enoch Success Boakai, and I'm here to present our paper titled Proactive Approaches to IoT Network Security. It's actually a review paper where we categorize the threats affecting IoT system. I wrote the paper along with Sunil Badija at Mawardi University in Rajkot, Gujarat. Yeah, so basically the paper explores the security vulnerabilities in IoT networks, which have expanded rapidly across sectors like healthcare, manufacture, and urban management. Basically, our paper categorized these threats, evaluating potential solutions and examining their impact on operations and data privacy. In the paper, we also discuss proactive measures such as network segmentation, secure design, device design, and encryption and access control. Yeah, for the introduction, we all know IoT devices are transforming industries, like in healthcare and smart homes and smart transportation and all. So within the research, we did how we look at data breaches, unauthorized access, and DOS attacks as well. So proactive approaches can be taken to protect the IoT landscape, like encryption, secure device design, and behavior analysis are also some of the techniques that can be used. The figure here on the slide shows a generic IoT network architecture where we are seeing interconnected devices interacting to exchange data and achieve functionality. So IoT network security threats. Within the paper, we classified IoT security threats into two main types, where we have the active threats and the passive threats. So for the active threats affecting IoT ecosystem, we have DOS attack, which is the denial of service attack. We have unauthorized access, botnets, and physical attacks. So these types of attacks aim to disrupt operations, and they are usually noticeable within the active threats. And for the passive threats, data breaches, side channel attacks, so these are all types of some passive threats in the IoT network. These types of attacks are more covert, okay, meaning they are harder to identify or to detect. And these threats brings about economic losses, operational disruption, and reputational damage as well. So just a run through with the proactive security approaches. To address these challenges, within our paper, we recommend the following proactive measures, which is the first, network segmentation. We actually made a research to come up with methods on how to divide the networks to limit the spread of these attacks. We also suggested encryption methods where we have to secure the data using transmissions using algorithms like AES. And we also recommended authentication and access control measures. Regular updates as well, like where we have to patch vulnerabilities within the IoT devices to promptly enhance the device security. Intrusion detection and prevention system is one of the proactive measures which can be taken to safeguard the IoT networks. So strategic amelioration techniques, we came about with the behavioral analysis where it's used to detect anomalies in IoT device behaviors and threat intelligence as well. So for the strategic amelioration, actually the difference between the strategic amelioration techniques and the proactive techniques, those are measures which can be taken to prevent the attack on the IoT network. Whereas for the strategic amelioration techniques is when the breach occur or when the attacks occur, these are strategies or techniques that can be taken to get the system back up, up and running. So for the amelioration techniques, we have behavioral analysis, as I said, threat intelligence, incident plans, and secure device management. We'll look at the challenges and future directions of the work, the research work. So by nature, IoT devices have resource constraints, okay, meaning because they are devices that are very low in resource and computational power. They also lack they have network complexity because IoT is incorporated in diverse networks, each having separate uses, collecting data through sensors and actuators and other stuff in the surrounding, and trying to process this data and be able to come up with decisions or make solutions. It can be challenging for the IoT devices. So another issue is interoperability. Interoperability issues is one of the challenges that is found within the IoT networks. So these are emerging technologies within IoT. These are emerging technologies which are promising to give good solutions to tackle these challenges which are seen. So here on the list, we have on blockchain, which offers a decentralized security method. We have AI for enhancing the threat detection, quantum encryption, and edge computing. So IoT growth necessitates robust security measures. That means the rapid growth of IoT device, it actually calls for robust security measures. We have to put these measures in place to be able to protect the IoT ecosystem, and some proactive strategies like, as I mentioned, network segmentation, encryption, combining with emerging technologies which are presented like blockchain and AI. This can help to continuously protect the IoT landscape. These are some of the things we research within the paper. Continuous innovation and collaboration are also essential for safeguarding IoT networks in the future. So basically, these are some of the key references which were taken down, but there are actually more references within the paper. These are just few that are selected for the presentation. Any questions?
Yes. One question from my side.
Yes, ma'am.
What are the main proactive measures you have considered for ensuring the physical security of the IoT devices, particularly say in high-risk environments?
Come again, ma'am.
What are the main proactive measures you are considering for the physical security of IoT devices?
Okay, ma'am. So for The
Such as
main
like device manipulation may happen, so it should be get prevented, or any physical tampering of devices. So how you are going to take a proactive measures for this?
Okay, ma'am. Thank you for the question. So, some of the physical proactive measures which can be taken into consideration, we have like temper-resistant hardware. That's why within our research we talk about secure by design, where when the IoT devices are being created from the onset, security measures have to be implemented within them so that they can be able to resist some physical tampering and access control mechanisms so that the attacker will not be able to compromise them.
Okay, and are you using any multi-layered
Come again, ma'am?
are you using any multi-layered security over here
Multi-layer security, can you?
in terms of device layer, in terms of network layer, in terms of cloud layer?
It's actually the network layer, ma'am. It's the network.
So are you using that, implementing here in IoT networks?
Yes, yes, yes.
Okay, so what are the benefits of this?
So the benefits of this it's going to help to secure the IoT network against emerging threats, like as I discussed in the slide, in the proactive security approaches slide. It's going to help to encrypt and safeguard data in transit, data in transit, and also authenticate and access and authentication and access control to prevent unauthorized access.
Okay, and what is the future scope you are planning for this?
So, ma'am, actually, this is a review paper, but we have reviewed current trends in the IoT network security, and then we also presented these proactive and strategic amelioration techniques. So, future scopes will include these emerging technologies where we can integrate the blockchain and the AI to enhance threat detection and decentralized security.
Okay, thank you.
Okay, ma'am.
Thank you, sir, for your presentation. Moving on next, I'd like to call Mr. Savji Krishna for his paper titled Quantitative Finance with RDDPG, a recurrent reinforcement learning method for stock trading automation. Please, can you start with the presentation?
Yes, ma'am. So, good morning, everyone. My name is Sauji Krishna, and I am from Amrita Vishwa Vidyapeetham. Today, I am going to present our work on quantitative finance with RDDPG, a learning method for automatic stock trading. So, this was a research which have a collaborative effort with our co-authors. So, let me start by introducing the core motivation behind our work. So, traditional deep reinforcement learning, or simply DRL, has been effective in stock market prediction. However, it has its limitations, like it requires extensive environment interactions which are impractical in real financial markets. And also, the real world introduces complexities like volatility, transaction costs, and also liquidity constraints. Our solution, the recurrent deep deterministic policy gradient RDDPG, addresses these challenges by directly integrating the uncertainties into the learning process, which enhances the robustness and improve decision making and also forecasts performance better in volatile markets. So next, coming to problem. So here's the problem we aim to solve. Generally, stock markets are non-linear and highly dynamic, making traditional models ineffective. So, financial data is a sequential requiring models that handle temporal dependencies. So, simulation often fail to translate well to real world conditions because they ignore factors like transaction costs and volatility. So our approach combines LSTM, long short-term memory, and DDPG, deep deterministic policy gradient, to handle with long-term dependencies and continuous actions. So this allows us to adapt to uncertainties and make better trading decisions. So next, coming to literature review. So to understand like where RDTPG stands out, and so we have compared with some already existing models like hidden Markov model, policy gradient, and DQN, which means deep Q network, and A2C, and also DDPG. So we can see hidden Markov model generally struggles with long range relationships, and similarly policy gradients are slow due to poor local maxima, and in DQN it generally fails at handling the continuous actions, and A2C generally suffers in volatile markets due to its high turnover cost, and even deep deterministic policy gradient sometimes overlooks the time series nature of the stock data. So RDPG bridges these gaps with a recurrent structure. Like we have integrated the LSTM model, which will learn temporal dependencies, and deterministic policy gradient helps to handle the continuous actions. Next, coming to so this is our high level design of RDDPG. So here we can see that it inputs the historical stock data and some of the technical indicators like RSI and MACD, and several market conditions. So we have taken the data from Yahoo Finance of Dow Jones 30 stocks of 8 years, like from 2008 to 2020. So here, then the LSTM module extracts the temporal patterns to represent the financial data, and the DDPG framework optimizes the trading actions using actor critic methods. So finally, the system outputs the trading signals like whether to buy or sell or to hold an stock, and also the performance metrics like Sharpe ratio and cumulative profit. So next, coming to the methodology. So our methodology is structured around RDDPG and LSTM. So firstly, LSTM handles the feature extraction like from sequential data, and DDPG learns the trading policy. And there are also other components like buffer, mainnet, and targetnet. And also this helps to stabilize the learning. In training, the system iteratively selects the actions, then evaluates the rewards, and then updates the policy using the gradients, and refines the network with soft updates. So next, coming to our experimental setup. So this is our overall experimental setup where we have dataset, model configuration, and trading environment, and also the comparison baseline. So dataset, as I have already told, we have used that Dow Jones 30 stocks, and the time period is like 2008 to September 2021. Where we have trained the data up to 2020, and for the testing purpose we have used the next 1 year's data. So then key performance metrics include the Sharpe ratio, cumulative returns, and final portfolio value. Then the model configuration, like we have some hyperparameters like learning rate, buffer size, and batch size. So they are here mentioned. And at last, we have also compared our RDDPG against several
Excuse
conventional
me,
methods.
sir.
Yeah.
Can you please wrap up a bit quickly?
Yeah. So next, coming to the results, it is so we can see here that RDDPG have achieved 45.85%, which have outperforming the DDPGs and other conventional methods. And then coming to conclusion, so these are our key findings, and Then, so yeah, this are conclusion and future work. So in conclusion, RDDPG outperforms traditional models like DDPG by integrating the recurrent layers for better decision making, and it adapts to market fluctuations and captures long-term dependencies, and also delivers superior performance metrics. So making it makes it a promising approach for optimizing trading strategies. And future work, we are looking ahead to plan like we want to integrate this RDDPG into FinRL. So in FinRL, we have only up to DDPG. So this RDDPG will make a difference for them, which can handle long-term dependencies. Yeah, that's from my side. Thank you. These are our references.
Okay, Sarah. Single question from my side.
Okay.
How do you see this application of deep performance learning evolving in this financial market over the next 5 to 10 years, sir?
So yeah, we mainly worked on the fluctuations period. Like we have trained up to 2020, and it was a period of Corona. So we thought that can we predict this in that Corona period also? So in further 5 years also, even though there might be some fluctuations of different factors, so we are thinking that if we use this technology, we can betterly handle those fluctuations also, and we can train this on more data like the last 20 or 30 years also, so we can get better results.
Okay, thank you.
Thank you.
Thank you, sir. Moving on next,
Excuse me, ma'am.
I'd like to, yeah,
Okay, continue.
yeah, I'd like to call Mr. Izzeluddin Nazi, sir, for his paper titled Advanced Arabic Speech Recognition Through Dilated Convolutional LSTM Networks. So please, can you start with your presentation?
Okay.
Sir, please, can you start?
Am I audible right now?
Yes, sir.
And also the screen is visual. The
Yes,
screen
sir, it
shared.
is visible and you are also audible. You can start.
Okay. My name is Izaldin. I'm representing my paper title as Advanced Arabic Speech Recognition through Related Convolution and LSTM Network. First, I will go through the overview, the introduction, literature review, methodology, discussion, conclusion, and also the references. Then speech recognition, also known as automatic speech recognition or speech to text, just a technology that enable computer to understand and interpret the human speech, and also converting speaker language into written text or executable command. We have four types of speech recognition: the individual word, individual words, connected speech, continuous speech, spontaneous speech. I will our speech recognition consider the individual words recognition. As you know, the our title is for Arabic language. Arabic as a language spoken by over 400 million people worldwide, which present unique challenges in speech recognition due to its complex language structure. The language rich morphology, original dialect, like people in Gulf they speak in different accent. Egyptian they speak in different accent. Like Syrian also they speak Arabic challenges. The first one is the dialect variation, which is we say Arabic has numerous dialects. Variation. This variation depend on can be when in the on the trips inside one country, the regions or country. These also the dialect is different from the modern standard Arabic, which is used in the formal writing and formal communication. The second one is the rich morphology. Like Arabic is known for its non morphology. One word can have many forms based on gender, number, tense. This increased the vocabulary size and result in high degree of word formation and variation, making it like challenging for ASR speech recognition to to predict the word accurately. The third one is the phonetic probability, like the pronunciation of certain sound can vary across region, adding another layer of complexity. Like if the letter like G in English, some people they will pronounce it G, some people they will pronounce G. Like the limited resources and also data set for Arabic speech recognition compared to English and other language, like they still like behind. The research objective, our research aim to develop speech like speech hyper specialized hyper architecture capable of handling the Arabic unique characteristics, while at the same time improving system ability to handle their variation. The primary goal includes achieving high command recognition accurately, ensuring like applicable, maintaining system robustness, and using process efficiency for practice and implementation. The significance of the study highlighted the unique challenges of the Arabic language, including the rich morphology and the dialect variation and the phonetic characteristics just we have discussed before, and also introducing advanced methodology that combine the CNN and LSTM deep learning to create more accurate and robust Arabic speaker recognition system. These are some of the research review I have done. Like the methodology, well, our method start by by the data pre-processing, then we pass through the feature extraction using the MFCC, and then we go for data preparation and organization like data splitting. Then finally, let's design and implementing the hyper CNL LSTM architecture. This is like the architecture we have used. We have like we start with the first convolution layer. Then we go through like 4 related layers with the deletion rate of 8 and 4, and then pass through batch normalizations. Then we pass it to LSTM layers, and finally dense layer. Then last for layer which the softmax layer for the prediction. Like the dataset we used the public the available dataset named as Arabic speech command datasets, which comprises of like 12,000 records collected like our collected by 30 people, each like for 40 unique commands. Like each command will be repeated by same person 10 times. The data pre-processing, we start with the audio processing using the LibreSer, like by down sample all the sample to 16 kilohertz to ensure consistency across all the sample, and also reducing the computational complexity compared to the original audio, which was 32 kilohertz. We also employ label encoder to convert the categorical label into integer values. Like for each word will be have an integer number. The feature extraction, we use the MMCC, and we take like a 40 MFCC coefficient per audio file to capture the essential characteristics of the Arabic speech. The data splitting, for the data splitting, we use like a traditional method for data splitting. We split it like 85 for training and also 15 for validation. The model architecture, as we just as explained before, it contains like the CNN and LSTM. The CNN component component is like this. We started with the first CNN with the initial layer with the deletion rate of 1, which will be like symbol without deletion. We followed by 3 layer using the kernel size of 7 and the progress deletion rate 2, 4, and 8. The LSTM component we have used like dual component. One layer was 256 layer, and the second one is 182, 128. We also use the advanced layer with 128 to, and also the last one with the softmax layer for classification across document classes. We just drop out of 0.5 for regularization. For the training process, the model was trained for 20 epoch. We also utilizing the adder optimizer with categorical cross-interpret loss. We also implement a validation checkpoints and also early stop mechanism to prevent the overfitting while maintaining optimal performance. Like our model, the result, our model achieve exceptional performance across all the key metrics with an overall accuracy of 99 on the validation dataset. The system also demonstrates the
Excuse me, sir.
remarkable
Can you
consistency.
please wrap up?
This is also the training validation accuracy. This is the confusion matrix. This is also the comparative analysis we have done with our with our paper, which we have achieved more than the last one, which is 97.9. This is the conclusion. The conclusion: we make a significant contribution to the RBX recognition technology, achieving a high accuracy, which is 99. This our work not only advances the field of RBX recognition, but also open up the possibility for practical application in various domains. This is the reference we used. Thank you for listening.
Am I audible, sir?
Yes.
Okay, so my question is, how do you handle out of vocabulary words or any unseen words during the recognition process?
Actually, we have only specific classes, like the 30 classes we have trained our data only for this specific classes, not all the words.
Okay, so you are not
It's
using
like
any software
specific command.
tokenization or any things?
No, we use only label encoding because we have it's like only command like open, close, down, up, left, right.
Okay, fine. And how does the system will handle any continuous speech recognition where the model must process the long audio streams that is provided?
For continuous speak recognition is a different. We can we can handle it different brief processing. You can start with character tokenization, word tokenization. You will have word for architecture for sequence modeling or language modeling for all of that. This only like command recognition.
Command. Okay, fine. Thank you.
Thank you.
Thank you, sir, for your presentation.
Okay.
I sincerely thank all our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, in behalf of the whole team, thank you for the support during the 9th version and all the previous 8 versions of this conference. We will be happy to have you in the 10th version in 2025. All the presenters would be getting their digital certificates via mail within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICTCS 2024. I'd also like to thank our session chair, Professor Dr. Deepika Birari ma'am. This is a token of appreciation to the chair on behalf of the team, ICTCS 2024 and the Global Research Foundation and partners. Thank you, ma'am, for
Thank
your
you so
valuable
much, ma'am.
presence.
Thank you.
Thank you. Now, I'd like to request everyone to switch on their cameras for a quick snapshot. I request everyone to please switch on your cameras. Okay, thank you, everyone.